Imagine this: the world, as we know it, is gone. The bustling cities, the endless chatter, the billions of lives. Vanished. All except for two. Meet Ethan and Chloe. Two final survivors of an apocalypse. And by some cosmic coincidence, they're both attracted to each other. So, the ultimate question hangs in the silent air: can Ethan and Chloe repopulate the planet? You know the stories, Adam and Eve, the foundational tale of humanity. Or perhaps you believe we came through evolution, a topic for another video. But right now, let's zoom in on our two lovebirds, the mysterious disappearance. You might wonder, how did Ethan and Chloe end up in such a bizarre situation? Was it an asteroid? An AI uprising trying to save humans from themselves? No. There was no big, cataclysmic event. It all happened by chance. Or so they think. Ethan and Chloe simply woke up. And everyone on the planet just disappeared. Gone. You might think, how is that even possible? Surely they'd know how. But no. They're just two normal folks, waking up in two different places, at the same time. They only know what they already knew. There's no way they could know everything. It's simply impossible. Freedom and frustration, the limits of no limits. Now that we've cleared things out, let's talk about their chances. And what they actually do. Is this a good thing for Ethan and Chloe? Or a crushing hell of responsibility with everything counting on them? Well, they were just like any other human. They weren't going to lose the opportunity to have everything for themselves. No law, no one to enforce it, they were free to do anything they ever dreamed of. But eventually, they'd go back to their roots. Because, surprisingly, they got bored. Crossing limits is what made things fun to try in the first place, but when there's nothing keeping you from crossing any limit, the fun wears off. Limits are there for a reason, so nobody gets hurt. And Ethan and Chloe did get hurt a few times before coming to the realization, it just wasn't worth it. After all of that, Ethan and Chloe finally decided. They wanted to repopulate the Earth. And here's where luck plays a huge part again: they are not related. This gives a huge boost to their chances. But let's be absolutely clear, this isn't just about having some kids. If humanity is to have any hope of truly recovering, Ethan and Chloe, and then their children, and then their grandchildren, and so on, would need to produce a massive number of offspring. We're talking about a multi-generational baby boom on an unprecedented scale. The survival of our entire species would depend on their relentless fertility and the willingness of every subsequent generation to bump a lot of kids. Because studies clearly show, if two related individuals have children, even if those children survive, they will have a significantly higher chance of birth defects and a higher mortality rate. Ethan and Chloe's first few children might be born healthy. But what about the offspring of those offspring? The offspring of those offspring? Will they be healthy as well? Now we run into a major difficulty. This scenario, starting from just two individuals, creates what scientists call a genetic bottleneck. It drastically reduces the genetic diversity for all future generations. While Ethan and Chloe aren't related, all their descendants will be, simply because they share common ancestors, Ethan and Chloe themselves. Numerous studies highlight the risks of a reduced gene pool. For instance, research on populations with high rates of consanguineous marriages, where spouses are related by blood, consistently show elevated risks. The chance of inheriting a recessive genetic disorder, which usually only manifests if a child receives two copies of a faulty gene, one from each parent, skyrockets because related individuals are much more likely to carry the same hidden faulty genes. A study conducted between 1933 and 1970, for example, looked at the children of parents who were first-degree relatives, like siblings or parent-child. This is the extreme end of consanguinity. In that study, an astonishing 40% of children born to first-degree relatives had a disability. And 14% died from those disabilities. That's a staggering number, though thankfully not directly applicable to Ethan and Chloe's first children. It illustrates the rapid increase in risk when genetic diversity is severely limited. Even with first cousins, the chance of a birth defect can double the norm of the general population. Beyond single gene disorders, a severely reduced gene pool can lead to lower overall genetic resilience. This means future generations could be more vulnerable to diseases, have weaker immune systems, and face a higher prevalence of multifactorial diseases like heart conditions or diabetes, as deleterious mutations accumulate over generations. In fact, many scientists propose that for humanity to maintain long-term genetic health and avoid these pitfalls, a minimum effective population size of around 960 individuals would be required. Ethan and Chloe are starting from just 2. They would need to be incredibly lucky in the genetic lottery, hitting the jackpot not just once, but countless times across generations. We have a good historical example of how keeping things in the family can have long-term genetic consequences. A man who you might think was trying to increase the population of his country, though perhaps for different reasons, King Chulalongkorn of Thailand. He ruled from 1868 to 1910 and did a lot in terms of modernizing his country. And, well, he was a formidable baby maker, just like his father, King Mongkut, who had 82 children. But here's the thing with royal lines. To keep power within the family, they often married close relatives. King Chulalongkorn himself married 4 half-sisters and had numerous children with them. While his immediate offspring were mostly healthy, the long-term genetic impact of such practices could be observed in subsequent generations. You saw increased instances of certain genetic conditions and a general reduction in the vigor often seen in highly inbred. However, it's not always a death sentence. Nature, and human intervention, have shown some remarkable comebacks from even more extreme situations. Take the New Zealand black robin. In 1980, its population plummeted to just 5 individuals, with every single one of today's black robins descended from a single female, affectionately known as Old Blue. That's a bottleneck from effectively one breeding female. Or consider the northern elephant seal. Hunted to near extinction in the 19th century, their population was reduced to a mere 20 individuals. Today, they number in the hundreds of thousands. The European bison, or wisent, also faced a dire situation in the early 20th century, with all living individuals descended from just 12 animals. These species recovered their numbers, which is a monumental feat, but here's the crucial point for Ethan and Chloe. While they bounced back numerically, their genetic diversity remains incredibly low. This makes them more susceptible to diseases and less adaptable to environmental changes. They carry the genetic scars of their near-extinction event. It's a stark reminder that survival isn't just about numbers, it's about the richness of the genetic library. So, for Ethan and Chloe, while they start with an ideal non-related pairing, their future generations would face an ever-shrinking gene pool. Each subsequent generation would inherently be more related to each other, increasing the risk of genetic issues, of disabilities, of a slow, biological collapse. The sheer, relentless pressure to reproduce, to ensure every healthy child has many more, would be an unimaginable burden. What do you think? Is repopulating a deserted Earth a gift or a curse for our last 2 humans, Ethan and Chloe? They might have the whole world to themselves, but the biggest challenge isn't conquering the land. It's conquering their own biology. I think you have your answer.